Hello my dear friends. So in this video we are going to see a security system using Arduino and laser sensor. A very simple project and very much useful project. So we can do it in our home and we can fix it to enable the security in our house. Let us see what are the components, how it is designed and how it is working now. So the main component of this project is a laser sensor which has a laser diode. So the laser diode is very much similar to the normal PN junction diode and normal LED, but the LED gives the light emitting diode gives the light in multiple wavelengths. The laser diode gives the light in a single wavelength, and the LED lights spread across, but laser diode light which is emitted will be focused a single beam light. So this is the simple difference between the LED and laser sensor or a laser diode. So this is the laser diode which we are going to use, KY008, so which is very much available in the market, which emits 650 nanometer wavelength laser beam, and it operates with the 5 volt DC signal or DC supply, and the operating power is 5 millivolt and the operating current is less than 540 milliamperes. It has a simple connection. We have power supply, ground and signal pin. So the signal pin is the one which will be connected to the Arduino or controller. So this is the connection to check whether the sensor is working or not. So we have 5 volt and ground pin, and then we have connected the signal pin to Arduino. So this is the code to verify the laser sensor. So I have connected the signal pin to Arduino pin number 7. So I have declared this pin to be in pin number 7. So where I connect the sensor, and this is the output pin. So laser pin is a output. I am declaring it as a output pin, and I am going to write a code to on and off the laser signal for 1 second. So digital write laser pin high, that means light will be on for 1 second, and after that it will be off for 1 second. So it will emit the laser signal for 1 second and it will off for 1 second. So the loop continues. So if you can able to see the light signal for in this pattern, so that means your sensor is properly working. So this is a circuit connection where we have power supply unit and controller unit, display unit and sensor units, and of course there is an output device. So if you see here, we have transformer, so which will step down the transformer supply voltage 240 volt AC to 9 volt or 12 volt, whatever the transformer you have. And we have a bridge rectifier, so which will convert this 9 volt AC to pulsating DC, and later this pulsating DC will be passed through the filter unit, so filter capacitor. So this filter will remove the noise and it will send the output to the regulator. So the regulator will regulate the output to 5 volt. So you get a 9 volt AC here, so at the regulator output you get 5 volt DC, a regulated DC, so that is a constant 5 volt DC. So this 5 volts supply will be given to your Arduino board and sensor and LCD and wherever it is required. In case if you want to implement this project in your house, so you can replace this part with a normal adapter, 9 volt adapter or 6 volt adapter with 1 ampere current rating. So if you replace this part, so you can plug that power supply to the Arduino directly here. Okay, so the next component is Arduino Uno, so which is going to act as a controller, where you are going to write a code and which will read the input and send the output according to the code which you have written. Okay, so the laser sensor is connected to the number 2. Okay, fine. Okay, so then we have a reset push button, and we have LDR. So the light will be emitted from the laser sensor, and if the laser sensor is emitting the light and the LDR is receiving the light signal without any interruption, so that means the system is in normal operating condition. If you abstract this light signal, so the LDR will not receive any light, so that means this will be detected back by the Arduino, and according to the code it will create a sound in the buzzer, and also it will display the information in the LCD. Okay, so once the alarm is activated or the buzzer is activated, so the concerned person will reset this using push button. So instead of this push button, we can have other mechanisms like RFID card or any other mechanism we can use, so that the access can be controlled to only authorized person. And also, instead of only this buzzer, we can use a GSM module to send a message to a concerned person or police station or something like that. This can be changed as well. Probably I will do that one as well. I will give it in the next video. Okay, I will change this push button to RFID, and I will try to change this buzzer into buzzer, as well as I will include one GSM module so that it will send the message to the concerned person. Okay, so now let us see the code. So in the code, though it is looking bigger, but there are repetitive things like LCD informations and all those things. The logic is very simple, you can understand. So first we need to include the liquid crystal header file, and we need to declare the pins. So we are going to use 12th pin for chip select and 11th pin for enable pin, and remaining 4 pins for data pins D4, D5 and D6, D7 is connected respectively from 7, 8, 9, 10. And then, so this is the pattern, liquid crystal LCD. So these numbers will be come here in the array. Okay, so this is for these 3 lines for declaring the LCD informations, and we are declaring the 6th laser pin, that is signal pin, which is going to be connected in number 6, and sensor pin, so LDR. So LDR is going to be connected in A0, so because LDR is a analog sensor, so which will give the analog signal, so it will be connected in A0. And the button pin, so where we are going to use it for resetting, so it's going to be connected in pin number 2. And the buzzer pin, so which is going to create a sound or alarm, so will be connected in pin number 3. So this int laser threshold is the initial value, so which we set as 50. It can be even 10, 20, whatever you need. Okay, so in the setup we need to begin the lcd.begin 16,2, because it is having a 16 characters and 2 lines. And LCD print, so the system name is going to display here, security system. And pin mode, laser pin output, so laser pin is going to emit the signal, so it is going to act as an output. Pin mode, button pin, so where you are going to push and reset the system once it is activated, so it is going to act as a input pin. And so boolean alarm state equal to false, so this is again initial declaration. So now in the loop, what we are going to do, we are going to do 2 things. One is if the alarm is on or the alarm is in off condition. Based on that, 2 works we are going to do. So first condition, we are going to check whether the alarm is in on condition. If alarm state equal to 0 or alarm state is not on, so what should be happening? So that means the system is secured, so there is no alarm raised now. So what should be happening now? So here it will create some delay, then it will enable the laser pin high, so that means the laser will emit the signal now from the laser source, and the LDR will be start receiving the signal. So like this, the laser will emit and the LDR will start receiving the signal. So once the light is start emitted from the laser, the LDR will be getting the signal. So here int sensor value equal to analog read of sensor pin. So sensor pin is nothing but a LDR where we have connected the LDR. So whatever the signal we are receiving in the LDR will be read in this line and stored in this register called sensor value. So once you get the value here, so we are going to print it in the serial port, as well as we are going to you make use of this to make the sensor to be the alarm should be on or alarm should be in off. So if the sensor value, whatever you are getting the LDR value, if it is greater than the threshold, so that is 50, then the alarm state will be true. Otherwise it will go back to off state itself. It will maintain in the off state itself. Okay, so if the value is more than this, then only it will change position. Otherwise it will make the laser pin to low. Okay, and then if this condition not there, if the sensor value is not in this threshold point, then it will come back to this point. It will make the laser pin low, and then it will say system is secured, because the alarm is not activated, because the sensor is not having the value which is more than threshold value. And then, so this is one condition. So if this condition is not satisfied, sensor value is lesser than the threshold value, or greater than the sensor value, so that means what will happen? So in case if you have sensor value of 60 or 100, so that means alarm state will become true. So if it is true, then what is going to happen here? The else condition. So this is if condition, and this is going to be else condition. So tone buzzer pin 450. So this means the buzzer pin is going to be activated, and this is going to be a value which will create a sound. So if you increase or decrease this number, the sound will increase or decrease. So LCD clear off, and we are going to just print it. So these are just to display the values. Okay, so alarm is activated. Okay, only that. And if not, the digital read pin. So that means if the alarm is activated, so the next is, so until when the buzzer will be on, until the buzzer this button pin is pressed. So if the button pin is not pressed, okay, so if the you see, if this button pin is pressed, so what will happen? Alarm state equal to false. So here we made it as alarm state true. So if the condition is met here, so here when if the push button is pressed, so then the alarm state will go to the false condition, and it will switch off the buzzer, and it will display that system is reactivated. So this is what is going to happen. So only a few things, that it's very simple. So we have to see the alarm state. If the alarm state, if the system is not giving alarm, then it will go inside. Then it will set the laser pin high, and the analog signal will be received in this analog sensor value, and it will compare to the threshold. If it is more than this value, so it will make the alarm state true. Otherwise it will be in a false condition itself. And if this condition is in false condition, then it will go to this digital write laser pin low, and it will say system is secured. In case if it is greater, if it is set to true, then it will come to this else condition. If then this if condition is not satisfied, then only the else condition will come. So if this condition satisfied, it is going inside, that means the else is not going to actuate now. So in the next loop, then what is going to happen? Here you set is true, so it will come here. So this is not going to be in satisfied condition, then here it will come, and it is going to make a buzzer to be on. And what is going to happen here? It is going to display the system is activated, and it will be in activated state until you press the push button. So if the push button is pressed, so that means then it will come inside this loop, and it will make the alarm state false, and the buzzer to be off. It will say system is reactivated. So this is the code explanation, and this is the implementation. We have implemented the sensor here. So this is the laser sensor, and we have a LDR unit here, and this is the power supply unit or a board. So instead of this only, I told you, you can buy a regulator, and we can give the supply to this Arduino directly. From the Arduino you can take the required place wherever you need this signal. And this is a LCD display and the required accessories. So this also you can use I2C uh, adapter or I2C, this one backpack, so that you can avoid these connections as well. You can connect only 4 pins to the LCD. And this is a buzzer unit and a reset button. So here instead of this button, we can use some RFID or something like that. And here instead of the buzzer, we can also connect a GSM module or any other mechanism which will communicate the information to the next level. Implementation video. So you can see here, this is the implemented system. So actually what happened now, I abstracted the light signal here so that the LDR is not receiving the signal. So the value will be more than 50. So when it is more than 50, so that means as per the loop condition, so the buzzer will create the sound. It will be creating the sound until otherwise I press the reset button here. Again I abstracted, so it is creating a buzzer sound, and I am going to reset it now. And you can see in the display, system are reactivated, and when it is resetted, it will say system secured, and when the buzzer is on, so it is going to show you alarm activated. So very simple and very much flexible. We can make all this device into a small box, and we can fix behind the door. And if anybody opens the door, the signal will be cut, and automatically it will create a buzzer, or it will give a information to the required people. Thank you. We will meet in another video with another useful project. Thank you for watching. Thank you.